Let's have a look at this question. The question is there a relationship between math SAT scores and the number of hours spent studying for the test? A study was conducted involving 10 students as they prepared for and took the math section of the SAT examinations. So in the left column we can find the number of hours studying for that test, and in the right column we find the score on the math tests. So here on the first line we have the first student. The first student studied 4 hours and had 390 on the math exam, and the second student studied 9 hours and the score was 580. So we would like to analyze this data and see if there's a connection between how many hours you study and the result you get on the math exam. Since we're going to start with linear regression, we're going to assume that the connection is linear. So the more you study, the better score you get, and there's also a linear connection between this variable and this variable. So let's go to our calculator and put in these values. I'm going to move them to the side here. You're not going to see them, but oops, I will be able to see them. Move that out of the way. So I'm going to just open a list and spreadsheet. I'm going to name the first column, the first variable, which is hours. I'm just going to put H. And then I'm going to enter the value: 4 hours, 9 hours, 10 hours, 14 hours, 4 hours, 7 hours, 12, 22, only 1 hour, and 3 hours. Now we can see that we're in line 10, so this means that we have 10 values. We're checking the values again. Everything seems to be fine. Okay, the second column is going to be the score, so I'm just going to write score. It's going to be the name, the variable name for the second column. Score, and I'm going to enter the score. So the student that studied 4 hours preparing for the exam had a score of 390. The student that studied 9 hours had a score of 580. 10, 650. So we are assuming that the more you study, the better you will do on the exam. And if we just look at these 3 students, it seems to be true. 14 hours, 730. Well, seems to make sense. 4 hours, 410. Pretty close to this result. 7 hours, 530. 12 hours, 600. 22 hours, the best score so far. 1 hour, only 350. And the last student, 3 hours, got a score of 400. Let's double check the values again, and everything seems to be fine. Now I would like to have a look at this this data in a scatter plot. So I'm just going to go to the home menu and choose data and statistics. And on this axis I will choose the number of hours, the variable age, and here the score on the y-axis. So since we're doing linear regression, we're going to assume that there's a connection between the number of hours we are spending preparing for the test and our score, and that there's a linear connection. So I'm going to explain the model that the calculator is using by doing it manually first, and then we'll let the calculator do this for us. So first I'm just going to add a movable line, and I'm going to try to move around, move the line around and try to make it fit all these points, which is of course impossible to have a perfect fit, but as close as possible. If I move the cursor here, I can move it up and down like this. If I move the cursor here to here, I can kind of rotate it. Okay, so I'm gonna look at these 4 points, try to make the line go kind of through the 4 points. Here it's a little bit more spread out, so let's see if I can kind of, I'm looking at this one, I'm also looking at these lines. This would not be a good fit because here most of the points are above the line, and this would not be a good fit because the lines are here. So we have to kind of compromise. As I'm moving the line, you can see that this is the equation for the line at the moment. So it is changing, right? So x is going to be the number of hours, and then if we enter any x value, for example 14, the y value will be possible to read here on the y-axis. So we can just enter any value for x, which is the number of hours, and then here the y value would be the expected score on the math exam. So it would be very useful for us to find a model, an equation, a general equation, assuming that this connection is linear, and then we can kind of predict our SAT score if we just enter the number of hours here, and we would know more or less what our score would be. So I'm trying to make something like this. Now it's pretty good. So what is the best line? That is the question. Well, one way to measure this is kind of try to minimize the distance from every point in the y direction. And so the idea is for this point, the distance should be as little as possible. And also for this line to the line, this point, sorry, for this point to the line, the distance from this point to the line in the y direction. So one way to do this is to, let's see, we can analyze and show the residual squares. What is this? Well, it's the distance from each point. Let's have a look at this point. The distance from this point to the line in the y direction, and then you square that. So let's pretend that distance from this point to the line is 10. Then we square that, so 10 times 10, or 10 to the power 2, which is 100. We remember this and add it to, we sum all the squares together. So the distance from this point to the line, square it, and add that to the distance of this from this point to the line, and square it, etc. So the sum of all squares is here, 24,525. If I move the line, I can see that the sum of the squares are changing, and the idea is to minimize this. You see, now it's increasing again because this is a very bad fit. Now we have all the points above the line basically. So 48,000, 43, we're going down, 28, 27, pretty good, 26, 23, let's see if we can get 22, 21, and now it's going up again, right? So it seems like around here the sum of all squares was the lowest, around here. And of course the calculator will do this for us. so we don't have to kind of try and move around the line and find the lowest value for this. So I'm just gonna go back and let's see if we can or actually I can just remove this line. I thought hide residual squares, and then I would like to remove movable line. Now I want the calculator to do this for us. Find linear regression model. So I'm just going to analyze and then go to regression, and then we have exponential, logarithmic, quadratic, but we're going to use the linear model. So an equation on this form, mx plus b, I'm going to choose 1, and here we have the equation for this line. So this line describes pretty much all these data, and we can also have a look at the residuals. Let's see, show residual square, and now it's only 18,500, so lower than we had. So this is the best possible line we can get using this model.